Continuing with the Math 1314 Final Exam Review, number 34. Given f of x equals 4x plus 8 and g of x equals 9x plus 7, go find f times g of x. We know that that's going to be f of x times g of x. What is f of x? It's 4x plus 8. And I want to multiply that by g of x, which is 9x plus 7. I'm multiplying two binomials, so I need to go FOIL. 4x times 9x gives me 36x squared. 4x times 7 gives me plus 28x. 8 times 9x gives me plus 72x. 8 times 7 gives me plus 56. Again, I FOILed. I did first, outer, inner, last. Now I need to collect like terms, 28x plus 72x, and my answer will be 36x squared plus 100x plus 56. For number 35, I'm given f of x equals 2x plus 5, and g of x equals 4 divided by x minus 2, and I'm told to find f plus g of x. By definition, that's f of x plus g of x. So I get 2x plus 5 plus g of x, which is 4 over x minus 2. I want to write that as one fraction, so I need to get a common denominator. I'm going to multiply 2x by x minus 2 over x minus 2 plus 5 times x minus 2 over x minus 2 plus 4 over x minus 2. I have a common denominator of x minus 2. In my numerator, when I distribute, I get 2x squared minus 4x plus 5x minus 10 plus 4. When I collect like terms, minus 4x plus 5x and negative 10 plus 4, my numerator becomes 2x squared plus x minus 6 over x minus 2. Then it wanted me to find the domain of that function. And again, I have a rational function. The denominator can't be equal to 0. When is x minus 2 equal to 0? I need to solve for x, add 2 to both sides, and I get x equals 2. So I know that my domain, x cannot be 2. How do I throw that out in interval notation? I say parenthesis, negative infinity to 2, parenthesis, union, parenthesis, 2 to infinity. Number 36, f of x equals x minus 1 over 3. G of x equals 2x plus 3. I'm to find the composition g composed of f of 10. To do that, we need to find g of f of 10. How do you find f of 10? In your f function, everywhere you see an x, you're going to plug in 10. So I get g of 10 minus 1 over 3. 10 minus 1 is 9. 9 over 3 is 3. So now I want to go find g of 3. Go to my g function. Everywhere I see an x, I want to plug in 3. So I get 2 times 3 plus 3. 6 plus 3 is 9. Number 37, given f of x equals the square root of x plus 4 and g of x equals 8x minus 8, find f composed of g of x. So I want to find f of g of x. Starting on the inside, what is g of x? Well, it's 8x minus 8. Now in my f function, everywhere I see an x, I want to plug in 8x minus 8 right here. So I get the square root of 8x minus 8 plus 4. That's the same as the square root of 8x minus 4. And I notice that I can factor out a 4. So I get 4 times 2x minus 1. Now remember that the square root of a times b is equal to the square root of a times the square root of b. That's the rule I'm using here. So this is equal to the square root of 4 times the square root of 2x minus 1. So I get 2 times the square root of 2x minus 1. Number 38, I'm given the graph of a function and I'm asked to state the intervals where it's increasing and decreasing. So from left to right, when I'm going up, I am increasing. Again, from left to right, going up, I'm increasing. So that's from negative infinity to 2. These are x values. For decreasing, from left to right, that's when I'm going down. So I'm going down from x equals 2 to infinity. Number 39, I'm given a quadratic function, y equals x squared minus 20x plus 105, and I'm asked to find the vertex. Here, I know that a equals 1, b is equal to negative 20, and c is equal to 105. To find the vertex, hk, h is equal to negative b over 2a, so I get 20 over 2 times 1. 20 over 2 is 10. To get my k, I plug 10 back into my original function, and I get 10 squared minus 20 times 10 plus 105. 100 minus 200 plus 105 is just 5. So my vertex is the coordinate 10, 5. Axis of symmetry is always x equals the x value of the vertex, so x equals 10. And it also wanted me to find the y-intercept. If I were to plug 0 in for x, I would get 0, 105. Number 40 says that Bob owns a watch repair shop. He's found that the cost of operating his shop is given by the function c of x equals 4x squared minus 368x plus 53, where c is cost and x is the number of watches repaired. So the question is, how many watches must he repair to have the lowest cost? How many watches? Watches was x. To find the lowest cost, this is a parabola that opens up. The lowest cost is going to be down here at the vertex. It's wanting the number of watches for that vertex, so it's wanting the x value of the vertex. How do you find that? H is equal to negative b over 2a. So I have negative 368 over 2 times 4. 368 over 8 is equal to 46. He must repair 46 watches per day to have the lowest cost. Number 41 says a toy rocket is shot vertically upward from the ground. Its distance in feet from the ground in t seconds is given by s of t equals negative 16 t squared plus 156t. At what time will the ball be 174 feet from the ground? So remember that this gives you the height, the distance from the ground. And it wants to know when will it be 174 feet from the ground? So I set 174 equal to negative 16t squared plus 156t. And I want to solve for t. This is a quadratic equation. To solve a quadratic, I need to get 0 on one side. So I'm going to move both of these things to the left. To do that, add 16t squared to both sides, and I get 16t squared minus 156t plus 174 is equal to 0. That does not factor nicely, so I'm going to have to use the quadratic formula that says t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. In this case, a is 16, b is negative 156, and c is 174. For time's sake, I've already written that out here. I plugged a, b, and c in. Then I simplified here. Negative 156 quantity squared minus 4 times 16 times 174 is approximately equal to 114.891. Okay, from here, I have 156 plus 114.891 over 32, and I get 8.5. I can also do 156 minus 114.891 over 32, and I get 1.3. So if I graph, I want you to look at the graph. Here's the graph of the quadratic. And then here's the height, 174. When does that occur? It occurs at two x values, here and here, or I should say t values in this case. So it occurs at 1.3 seconds and again at 8.5 seconds. Okay, number 42 says a farmer has a 100-feet roll of fencing with which to fence a rectangular grazing field for her new pony. One side of the field will be a barn. So I drew the picture and said, here's the barn. That's one side of the field. So the fencing will only need to be used on 3 sides. So here's the fencing. What should be the dimensions of the field so that its area is 1,250 square feet? Okay, so first thing I want you to notice, the dimensions of the fence. I have 100 feet of fencing, and it has to do these 3 sides. So x plus y plus x has to equal 100. That tells me that 2x plus y has to equal 100. So y has to equal negative 2x plus 100. Now I want to look at the area, and I want the area to equal 1,250 square feet. Well, the area of this inside here is going to be x times y, because that's a rectangle. And what was our y equal to? Negative 2x plus 100. So I have x times negative 2x plus 100. If I distribute this x out front, I get a quadratic function, negative 2x squared plus 100x. Now the question is, when will that area equal 1,250? So when will 1,250 be equal to negative 2x squared plus 100x? That's a quadratic equation, so I need to get one side equal to 0 so I can solve for x. Adding 2x squared and subtracting 100x from both sides, I get 2x squared minus 100x plus 1,250 equal to 0. Again, I've got to use the quadratic formula, and I've already written that out, where a is going to be 2, b is negative 100, and c is 1,250. I end up with x equals 25, because what's under the radical here ends up being 0. So when x is 25, what is y? Go back up here. My y was equal to negative 2x plus 100. So if y equals negative 2x plus 100, and I found out that to maximize my area, x had to be 25, y is going to have to be negative 2 times 25 plus 100. So negative 50 plus 100 is 50. So the dimensions of my fence need to be 25 feet by 50 feet.